Hi everyone, my name is Alexandre Cauquoin and I will present you, the title of my poster is High Resolution Isotope Modeling with ECHAM6-wiso for better understanding of the water cycle, where you can see a schematic just here. And this is one of the main components of the Earth climate system, and the processes there are numerous and complex. And one way to better understand them is to use water stable isotopes. So you can see them here. There is the H216O, the light water isotope, the standard one, and two other heavy isotopes in lower quantities, the H218O and the HD16O. And these water isotopes are integrated tracers of the climate processes that occur in this hydrological cycle. And through their measurements in natural archives, like here ice core, for example, or marine sediments, etc., you can reconstruct the past variations of climate, like here the temperature in Antarctica during the last 800,000 years with warm and cold period that you can see here. So this is for the data side, but now let's go to the model side. And one way also to better understand the hydrological cycle is to use a general circulation model. You can see here an example of such type. So these are complex models of climate, and especially models with isotope diagnostics in it. And with model data comparison, they helped a lot for better understanding of the water cycle. And especially for the modern period, we can use this atmospheric GCM nudged. It means guided with weather forecast reanalysis data. And this is really a powerful way to obtain model outputs under the same weather condition than at sampling time of the observation. And so here I will show you some new simulation with the new German model ECHAM6-wiso that are nudged with the last reanalysis ERA 5. So we did a simulation for the modern period, as I said, so for the last 50 years, 1979 to 2019. And we did several simulations in order to separate the simulation improvement due to a switch from the different version of model, ECHAM5 to ECHAM6. So you can see here the difference in the table here. By switching from the pre-analysis predecessor, ERA interim, to ERA 5. ERA interim stopped in last August, so we have now to switch to ERA 5, but we can see the improvement thanks to that. And also by increasing the spatial resolution from less than 2 degrees to less than 1 degree, so this is in orange line here. And usually the notation for water isotopes is delta 18O, so I don't detail here, but this is the variation of heavy isotopes on light isotopes. And here you can see on this plot model data comparison of delta 18O simulated against the delta 18O in precipitation, measured in precipitation. And you can see that for all the simulations, so these are the color scatter plots, there is a very good agreement, but slightly better agreement for the new version of ECHAM6, ECHAM6, so in blue and orange. And now if we have a look on the spatial relationship between delta 18O and temperature, you can see that compared to the observation in black, we are very consistent with the observation for all the simulation setup, and they are very similar between each other. Now let's go to the seasonal variability at a different station for different weather conditions, and we compare to the observation in isotopes, in temperature and in precipitation. And we have a slight improvement by increasing the spatial resolution, so in orange, but globally, despite that, the model results are pretty similar between them with more or less good agreement with the observations. And now we are interested, as I said, to see the impact of using new reanalysis ERA 5 instead of ERA interim. So here you can see the difference in delta 18O temperature and modeled precipitation. And you can see if you have a look here on the numbers, the difference is finally pretty low. But one of the aspects is the difference in terms of precipitation over the tropics. So we can expect some changes from this point of view. And finally, here you can see some model data comparison at very high temporal resolution, so daily or sub-daily at several stations of delta 18O in surface water vapor. So with like picker instrument that we have at the lab. And you can see that, quite surprisingly, the we have quite a good agreement, but the different model results are pretty similar again between each other. And this is the conclusion of the paper, that the increasing of spatial resolution improves the model data agreement slightly, and the use of ERA5 instead of ERA interim for nudging has impact on tropic weather patterns. And we hope that these model outputs will be very useful for the people who make isotopic data. Thank you for your attention.